Hello everyone, and welcome to the video for section 1.4 on combining functions. When we go through a combined function, we actually have a couple different ways that we can go through and do it. You should be familiar with generally both of them. One deals with all the operations that you're familiar with, and the other one is really where you're putting one function inside of the other, or what's called function composition. So, to go over this, our objectives for this video: number one, add, subtract, multiply, and divide functions. Number two, evaluate composite functions. And number three, determine the domain of functions resulting from operations on and or composition of functions. The conceptual objectives for this video: understand the domain restrictions when dividing functions. And number two, realize that the domain of a composition excludes values that are not in the domain of the inside function. First, let's look at the different ways that we can combine functions. And really, when we combine functions, we're looking at the basic operation. So the key part on this is notation. Making sure that you recognize the notation and what you're supposed to do with that, with the functions that you have. So in this case, what we're going to have, we have our four different operations: sum, difference, product, and quotient. Now the first three, the sum, difference, and product, really have a strong relationship in terms of their domain as well. So when we talk about the sum of two functions, the notation often is going to be in parentheses f plus g of x. I've also seen it written as f plus g of x, like here. I've also seen it as just f plus g. In fact, sometimes I'll write that as well. So that could be another one on here. But all of that means you're going to take whatever f of x and you're going to add g of x. The difference, f minus g of x, where f minus g is in parentheses, or without the parentheses, or again, just f minus g, and that is f of x minus g of x. Product. The product is f times g of x, or f times g of x, like this, without the parentheses, and that's f of x times g of x. Also keep in mind, there are times you might end up seeing the dot in between there too. But often that dot does have there is a mistake that happens with function composition coming up, and there's error that can happen with that dot. So a lot of times I don't use it, but you could also see it with the dot. And what happens though on this is that the domain of all three of these, the domain is just going to be the intersection. This symbol right here means intersection. It's going to be the intersection of the domain of f and the domain of g. In other words, the domain of a sum, product, or difference of two functions is really just going to consist of the elements of the domain of the domain of f and the domain of g actually have in common. That's what the intersection is, what they actually have in common. Now the quotient is a little bit different because you have an additional issue that comes into play. F divided by g of x also would be f divided by g, like this. Or again, you could just see it as f over g, and that means it's going to be f of x divided by g of x. And the other issue you have here, because g of x is in the denominator, we know g of x cannot equal 0. So the domain then of a quotient is going to be the intersection of the domain of f, the domain of g, and really the values of x that make where g of x does not equal 0. Any value where g of x is equal to 0 needs to be excluded. Let's take a look at a problem here. In this case, what we have is f of x equals the square root of x minus 1, and g of x is equal to x squared. And so with that, I'm going to just draw this line here. The first thing I want to do is let's talk about the domain. Well, I know in this case that the domain of f would be such that since it's a square root, I know it's going to be where x minus 1 is greater than or equal to 0. So that's going to happen when x is greater than or equal to 1. Or when I get the interval notation would be the interval from 1 to infinity. The domain of g, on the other hand, in this case, that domain of g, this is just a polynomial. I can use, I don't have any square roots, fourth roots, anything like that. I don't see any fractions. So the domain here is all real numbers, or as an interval, negative infinity to infinity. That means when I work with these functions, doing the combinations, at least for the sum, product, and difference, I know the domain of that is just going to be the intersection of these two. Well, really, again, remember, the intersection is just what this set and this set have in common. And what they really have in common is that x is greater than or equal to 1. So the domain here that we're going to be looking at is going to be where x is greater than or equal to 1, or as an interval from 1 to infinity. So all of ours are going to have that. In fact, even the quotient will also have that, because g of x is only 0 when x is 0. And so since 0 is not included in our domain that we have right here, then we know that that actually will also be the domain of that quotient. Now the way this works, when I do this, f plus g of x, what that's going to end up being is going to be where I take f of x, so that's going to end up equaling f of x plus g of x. That's what the notation tells us. And I know f of x is the square root of x minus 1 plus g of x, which is 2x squared. So what I'd like you to do right now, I'd like you to pause the video, and I would like you to go and write down expressions for f minus g, f times g, and f divided by g. You don't have to simplify, just write those down. Once you're done, come back and we'll take a look and compare your answers with what I have. Welcome back. So in this case, what you've seen right now is I've added in all the pieces, all the stuff that I came up with, and then hopefully it matches yours. With the difference that we have, f minus g of x, that's f of x minus g of x. So that's going to be the square root of x minus 1 minus 2x squared. F of x times g of x would be f of x times g of x right here. And that is going to be the square root of x minus 1 times 2x squared. Or you could write it this way here, 2x squared times the square root of x minus 1. I think a lot of times that's the way it would end up being written. It just looks a little bit cleaner. And then the last one is f over g of x, which is f of x over g of x, which then is the square root of x minus 1 over 2x squared. And again, remember, every one of these has the domain here of that intersection because of the fact that what's happening here, the only place that we would have an issue would be any place where 2x squared was equal to 0, but the only value of x that makes that equal to 0 is 0 itself, and 0 is not part of the intersection of the two domains, so therefore we don't even have to worry about it. So every one of these here has a domain of the interval from 1 to infinity, where we include 1. Next, let's take a look at another type of problem in which we are given the two functions here. F of x is x squared minus 1, and g of x is 3x plus 2. And what we're going to be asked to do in this case is we're going to be asked to go and we're going to evaluate the combinations of different functions, but we're going to have a specific value. So in this case, looking at the first problem there, I have f plus g of 2. So what I know is, notation-wise, that is going to be f of 2 plus g of 2. And what I have to do now is find f of 2. Well, that means I'm going to put 2 in for x into function f, and 2 squared minus 1, well, 2 squared is 4, minus 1 is 3. So I know f of 2 is going to equal 3. And then g of 2, I put 2 in for x in function g. I get 3 times 2 plus 2, so I get that 6 plus 2. I know g of 2 is equal to 8. So this problem just becomes 3 plus 8, and 3 plus 8 is equal to 11. So I know f plus g of 2 is equal to 11. What I'd like you to do right now, I would like you to pause the video, and I would like you to go and evaluate the 3 remaining combinations that we have. Please write it out, show the work like I did there. write it out, and then when you're ready, press play, and we'll go through the results. Welcome back. So in this case, let's take a look what you did. You should have gotten on this, you should have found that f minus g of 4 was equal to 1. You should have had f times g of negative 2 is equal to negative 12. And f divided by g of negative 4 comes out to be negative 3 over 2. Let's look at how this took place. F minus g of 4 is f of 4 minus g of 4. And I plug in f of 4, I put 4 in for x. That's going to give me 4 squared minus 1, which is 16 minus 1, which gives me 15. Minus g of 4, I put 4 in for x and g. I get 3 times 4 is 12, plus 2 is 14. So I have 15 minus 1, minus 14, equals 1. In the third one, f times g of negative 2. That's f of negative 2 times g of negative 2. F of negative 2, you put negative 2 in for x, is going to be 4 minus 1, which gives us 3. G of negative 2 comes out to be 3 times negative 2, which is negative 6, plus 2 gives me negative 4. So 3 times negative 4 is negative 12. And the last one, f of negative 4 over g of negative 4. Putting negative 4 in, I get 16 minus 1 is 15, so f of negative 4 is 15. And g of negative 4 comes out to be 3 times negative 4 is negative 12. Adding 2 gives me negative 10. So that negative sign can be brought out in front, so I can look at that as negative 15 over 10, which reduces to negative 3 over 2. Hopefully, that's what you came up with. If you didn't, double check your work, see if you can find the mistake that you made. And if not, make sure you come and ask about that in our next class. Now we get to function composition. Again, the big idea on this is we're going to put one function inside of the other function. Okay, so kind of to get started with this, I just want to refresh your memory on some things. We have right here, I have two functions, f of x and g of x. We'll just work initially with f of x right now. Okay, and in the past we've done some things with f of x. We've gone through with a function, we've evaluated the function at a number. So I've asked you to go and identify something like, let's say f of 2. And you went through and you put, I would ask you what you would do, and you'd tell me, oh, I put 2 in for x. So you ended up with 2 squared plus 2 times 2. And we were able to evaluate that. So now what we're going to do is look at kind of changing this up a little bit. You remember that what goes in, what was in the parentheses right there ends up going in for the variable. So what we're going to have is we're going to have something like this. We're going to have something that says f of, we'll go g of x. Okay, now remember that what that means is that we're going to put whatever is inside here goes in for the variable. So in this case, I go through and I can say, well, g of x I already know is 1 over x. So I can look at that and say this is going to equal f of 1 over x. And so I'm going to replace the variables with 1 over x. And when I do that, I'm going to get 1 over x, that thing squared, plus 2 times the 1 over x. That's what it means by function composition. I'm taking a function, one that is inside, putting it into another one. Okay? And if I simplify that, that will simplify to be 1 over x squared plus 2 over x. Let's see how you do with it. I'm going to ask you to find, I want you to do g of f of x. So pause the video and I want you to go and do that function composition, see what you come up with. Okay, welcome back. Let's take a look at this. On this problem, g of f of x. In this case, what I have, I know that's going to be g of f of x is x squared plus 2x. And so when I do this, I'm going to take what's inside these parentheses, that goes in for the variable. And so the result on this is I'm going to get 1 over the x squared plus 2x. Take a look. If you didn't get that, look at what I did. Look at how we went through and worked with that, and see if it clears up what mistake you may have made. Now that we've kind of looked at the idea of what function composition is, let's get to the notation, see what that notation looks like. And what you see here is the notation we have for function composition is, some people will look at that and they say, oh, what's the fog? Well, that is actually f, that's like a little circle there, that's of g of x. And what that means, when we look at a composition, there's going to be an inside function and an outside function. The inside function is what gets worked with first when you're working with function composition. And when we look at this notation here, the function letter that is closest to the x, that's the inside function. The f would be outside. So f of g of x is equal to this. It means this. So you have f on the outside, and g of x is being put inside of function f. We could also go g of f of x, and in that case, g is the outside function, and f of x is the inside function. Now let's take a look at another couple examples here. Okay, we have two functions. F of x is going to be 2x plus 1, and g of x is x squared minus 3. So, using this notation, what I would like you to do is pause the video, and I would like you to write down the expression. Just do the composition. You don't have to do any simplification. Just do the composition. Show me, write down what you think f plus g, or not f plus, f of g of x would be. And then once you have that one, do the same thing for g of f of x. So think back what we just talked about in the previous slide, and work on that one, work on these two right now. And once you're done, come back and we'll take a look at what the answers, what answers I hope you came up with. Okay, welcome back. You can see that I've now put my solutions to those problems. And again, remember I said I don't need you don't have to go and simplify them right now. You just have to, I want you to do the composition. So in this case, in this first one, f of g of x, you have to remember again, as was up here, that means f of g of x. So g of x is going into function f. So I'm going to take everything right here, and it's going in for the variable in function f. And so when I put this here, all of that in for that variable there, I end up with 2 times the quantity of x squared minus 3, close off that quantity, plus 1. So that would be my initially what I would have for f of g of x. I could then at this point distribute the 2 inside and combine the like terms, but for our purposes right now, this is sufficient just to see what that composition initially looks like. Now, for the next one, we had g of f of x. And again, in that one, g is the outside function and f of x is the inside. So we're taking function f and we're putting it in for the variable in function g. So we're taking all of this right there, and it's going in for the variable that we have in function g. And so in this case, when I make that composition, I will get the quantity of 2x plus 1, that quantity squared, minus 3. So hopefully that's what you came up with initially when you did your function compositions. If not, make a note of this. If you're not sure how I got those, make sure you put a note in your notes on this one, and make sure to ask that question when you come back when next time we are in class. Now let's take a look at what happens when we have to evaluate function composition. So what's going to happen here? we're instead of going through and doing f of g of x or g of f of x and having this composition with the variables, what's going to happen is that we're going to ask you to get a numerical value. So in this case, we're going to use f of x is 2x plus 1, and g of x is x squared minus 3. So the first thing we have is if I want you to find, let's say it'll be f of g of 3. Now, so that notation, you know what that's going to end up being, f of g of 3, and that's going to be put inside. So what you have right there, I'm going to take the value of function g at 3. So I'm going to put 3 in for x. When I do that, g of 3 is going to be 3 squared minus 3, which will be 9 minus 3, which equals 6. So I'm going to put g of 3, that value, into function f. So when I do that, when I work with that here, this is now going to be f of g of 3, which is 6. And so f of 6, we know, is going to be 2 times 6 plus 1, which gives me 13. The key part of this is that you have to recognize that when you see this notation, this 3 is what is the value that is going into the the inside function. That's the number you put in for the variable in the inside function. Whatever result you get after putting 3 in for the variable, that's what's going to go into the outside. So in this case, g of 3 came out to be 9 minus 3, which was 6. So f of g of 3 was equal to f of 6, which came out to be 13. Now I've added 2 more problems here. First one is f of g of negative 2. And the third one, this other one, is g of f of 3. And what I'd like you to do is pause the video, use what I have up here as a model to go through. I want you to evaluate f of g of negative 2 and g of f of 3. So go ahead, pause that video, pause the video, do those calculations, and then come back and we'll take a look, double check your answers. Hopefully your answers will match mine. So pause the video and come back once you have completed this task. Welcome back. So in this case, hopefully you got the same answers I did. In this case, that f of g of negative 2 came out to be 3, and g of f of 3 came out to be 46. Again, let's take a look at that, make sure, double check my calculations, your calculations. So in this case, f of g of negative 2 is going to be f of g of negative 2 is inside. I put negative 2 in for x, that gives in function g, that gives me 4 minus 3, which is 1. So that becomes g of negative 2 is equal to 1, so that's f of 1. When I put 1 in for x in function f, I get 2 plus 1, which is 3. And then the second one, I have g of f of 3, which equals g of f of 3. Now, f of 3 is inside. So I go through to function f, plug 3 in for x. That gives me 2 times 3 is 6, plus 1 is 7. So I know f of 3 is equal to 7. So g of f of 3 becomes g of 7. And when I put 7 into function g, I get 7 squared, which is 49, minus 3, which gives me 46. So that's how we came up with 3 and 46 for f of g of negative 2 and g of f of 3. Hopefully you got those. If you didn't, hopefully you now see where what mistake you made and have corrected that. If not, again, make sure to ask about it in class. Just two more problems for you to do. I'd like you to do these right now and put these at the end of your notes, and we'll take a quick look at them in class. So in this case, what we have is f of x is x squared plus 3, and g of x is 2x minus 5. And so what I'd like you to find is f plus g of 3. I'd like you to find that. And then I'd also like you to find f of g of negative 1. So go ahead, answer those questions, put them at the end of your notes, and we will check those in class next time. So with that, hope you have a good evening, and we'll see you in our next class.